Hello and welcome to another creative coding video. Today we're going to be trying to create antique looking maps like this one. And what I like about these kinds of designs is that they have a colour scheme which looks old. They look like they've been done with sort of old ink or old kind of pencil. I'm just going to run this code again just to see what other design pops up. These are sort of pseudo-random. So I like the fact that there's sort of an area of water, and then you can see some isolines, as it were, showing kind of depth underneath the water and the rise of islands. Let's try again and see what other design pops up. Yeah, so this is a kind of a great lake or a great sea, as it were, and you can see here the kind of isolines that show a little mountain or a hill with two peaks here. This one's got a sort of a softer peak, and this is probably some kind of valley. So you can see it's sort of realistic. So let's go ahead and write some code or develop an approach to creating these. The idea today that we're going to use is nothing particularly new, so it's practice of ideas that we've developed and learned about before in the videos that we've worked through. So we're going to be using the idea of noise rather than pure randomness. You should definitely go back and rewatch the video on which introduces noise and compares it to pure randomness. We won't kind of go over that again, but very briefly, if I kind of have random values, purely random, and I kind of plot them in a sequence, they kind of jump up and down in an unpredictable way, and that's the idea. Otherwise it wouldn't be random. And sometimes we want smoother but random variation, and one way to do that is to use something called purlin noise, and it does move randomly but in a much more smoother way, and that has so many uses, as we've seen throughout these videos. And you can have 2D versions and 3D versions, and in fact multi-dimensional versions of noise. We're going to use a 2D version of this noise to provide height data. It's not a new idea, we've done it before. So if we have our grid like we've drawn here, at any point we're going to have a value of noise that depends on the location xy, and that will provide a kind of a height value. So you can see if I had a kind of an elevation, I might have a surface. It's probably easier to see it, so let's code that. So I'm logged into Open Processing as usual, and I've got my Simple.js library enabled. We need that to keep our code simple. In the setup section, as usual, I've called simple to get that library kind of up and running. And I'm going to use a couple of loops to go across and visit every point in our canvas. So I'm going to say for var x equals 0. This should be pretty standard by now, this kind of coding pattern. So I'm going from 0 to 800, and I'm going to keep a count and increase it by 1. In fact, let's just do it by 5 to start with. So this is going to move across the canvas horizontally with x counting from 0 to 800, which is the width of the canvas, in steps of 5. And I'm going to have another inner loop which is going to move downwards. And the default canvas size here is 800 by 600. Now you might be asking why we're using less than or equal to, whereas quite often we were just doing less than. The reason is we want to include the last point. No, actually that's not right, is it? Because it goes from 0 to 799, so that's fine. It's good to think aloud and catch your own mistakes. It wouldn't have made any real difference, but it's just a little teeny bit more correct. So we're visiting every point, and in fact if I just draw a circle of size 3 at every point there, just to make sure that we are doing that. So when you're coding, it's useful at kind of intermediate points just to check your code is doing what it's supposed to. So let's run that. I should see a grid. Yep. In fact, if I jump at even bigger steps, the grid should be more apparent. There. Great. So we are moving across the entire canvas. Now we want to calculate a noise value. So if I say var n equals, let's add a comment. Comments are good. Noise. So others can see what we're doing with this code. So we can say noise x comma y. So the noise will depend on both those coordinates. Now noise goes from 0 to 1, so we will try and make it go bigger. Let's multiply that by, say, 200. And actually x and y goes from 0 to 800 and 0 to 600, which is quite quick. So let's divide that by 100 just to get the noise to move more slowly. If we use that as a color, for example, let's say fill n, just to see the effect. So red, green, blue is going to be based on noise, so we should get a grayscale. Let's draw a circle there, x, y, size, let's just say 3. We're not too bothered by the exact size, we're just testing at the moment. I'm going to remove up here the stroke on the circle so it doesn't have an outside no stroke. So I should see this 2D noise. You can sort of see it. Let's make those circles a little bit bigger. Let's make them size 10. They probably overlap, but that's okay. There. So you can see here what we've done is shown visually how noise changes across the canvas, and it's not in pure randomness, otherwise that would look more like static on an old TV screen. You can see it's changing gradually, and there's bits that are high valued and there's bits that are low valued. And you can see this could almost start to form the basis of a map where high values are high elevation and low values, the dark areas, perhaps are sea level or below. So that's the basic idea for our map. But we don't want to create a 3D map, we want to create a 2D old book illustration, as it were. So what can we do? Well, let's think about that sea level question and just colour anything below a certain level, say blue, something like that. So that should get us started. So we can say, if we can put a condition in, we can say if noise is less than, say, if it goes up to 200, let's just say 90, which is less than half. If noise is lower or equal to 90, we'll colour it blue to red. So red, green, blue, 0, 0, blue. And then we'll draw a circle there, x, y, 10. Else, otherwise we'll do this. So just to repeat what we're doing, we've generated noise for each point on the canvas, and we've seen how it varies relatively smoothly, and we can interpret the noise as height, land height, and if it's less than 90, we'll say that's going to be sea, water, and we'll colour it blue. So I'll put blue water. We'll do that. There. So that wasn't too difficult actually, and we're progressing towards what we want to achieve. So this has created a sea level, and in fact if we alter the threshold, if we say it's less than say 30, we'll get less water. You can see there's only a teeny bit there. Let's try that again. Yeah, there's not much water there. And if we make it higher, the sea level's higher, let's say 150 out of 200, then most areas will be water. So maybe 90 is about right. Of course you can play with this yourself to set your own proportion, as it were, between land and sea. Right, now let's think a little bit about the land. And what we want to do is to have a sort of a beige cream colour, but with isolines. Now how are we going to do that? Well, let's actually get the beige colour first and then think about those isolines. So for the land, which is above 90 in height, let's get the colour. Now you can use sort of an RGB colour picker, or use your favourite kind of image editing app to kind of find the right combination of red, green, blue. I had a little play earlier, and I think I found a combination. So I think it was 255, 229, 202. That I think is actually let's go to a color chart. So RGB color picker. There's one. Google has one as well. So you can kind of play with this yourself to find a nice sort of kind of beige color. The one I found was 255, comma 229, comma 202. There. It's quite light actually. Let's give that a shot. See what that looks like. Getting there. Now I'm going to increase the resolution so the jump across the grid, the steps aren't size 5 but size 1. And I'm going to make those circles a bit smaller. Like that. Let's see the effect that has. That should be more detailed, but something that takes a lot longer. So you can see now, this is a lot more detailed, and the edges are better defined, but it took longer to generate. And that's what happens because we've got more grid points to cover. Now let's think about isolines. Let's get our pen and paper to think about how we might do those. Now if we think about our problem just in one dimension, and we've got heights like this, so this is noise, just depending on x here, that's x. Now we would want isolines to be at certain heights, so at say height 10, 15, 20, we'd want to draw a line here, like there, and maybe one there, so that when this is in 2D form, this thing, if there's a peak, it might look like that. That's representing 20, the height, 20, and the next one would be something like that, and there's this one here, so it's there, and then the 10 would perhaps be like this. So this peak is that one, and this peak is that one. So essentially what we're doing is we're drawing lines at discrete heights, so at 10 and 15 and 20, or it might be every 2, 10, 12, 14, 16, but they're just regularly kind of spaced apart, or it doesn't even have to be regular, but they are spaced apart. It's not continuous. And that's what isolines are. They are lines marking particular heights. So this could be 2, 4, 6, or it might be 10, 15, 20. So we can do that. We can use a little bit of maths to kind of pick out those intervals. So if we've got a height like h, if we divide it by a number, say 10, and if the remainder is 0, if the remainder, so that means modulus, so that means whatever's remaining after h divided by 10, that means that every 10 this is true. So this is true when h is 10, h is 20, h is 30, h is 40. So we can use this as a condition for choosing when to draw an isoline. If we did h modulo 2, that would be true when h is 2, 4, 6, 8. So those isolines would be closer together. Let's experiment with that in code. So let's remove this for now, just so we got some clarity, and say, in fact, we'll just do those circles independently, the blue water independently, so it's got its own if statement. And here we're going to say if noise divided by 10, and then the remainder, so that's the modulo, equals 0, but it can't just be that, can it? Well, let's try it. If it's that, then draw a dark circle. So fill 0, this is black just to get us going, circle x, y, size 3. Let's see the effect of that. We should, I've caught a little thing. This is assuming that n, the noise, is an integer, a whole number, and it's not. It's going to be a continuous floating point number. So this could be, noise will generate values from 0 to 1, so it could be 0.56, 0.31, 0.989. So times 200 will make it bigger, but still have fractional values. So if we say int, that forces it to be an integer, chops off the fractional part. So 195.5 will become 195. Now when we say n modulo 10 equals 0, if it equals 0, that means n must be 10, 20, 30, 40. Let's try that. Some error. I had lost count of the number of brackets, so let's check I've got them right. So this one is up to there, this one is up to there. I need to close these two. That's it, so those two are up to there, and then this one closes the entire draw function. It's sometimes easy to lose track of your brackets. Great! We're almost there, look at that. I mean, this looks quite cool as it is, so it doesn't need a lot more done to it now. All we need now to do is just refinement, but this is, I like this is good enough as it is. So you can see that the lines, the black lines, are drawn where the noise is a multiple of 10, because that's when noise modulo 10 is 0. So this could be, I don't know, 70, 80, 90, 100 perhaps. But it also goes into the C when we don't want that. So we could put a condition in to say, if noise is a multiple of 10, and noise is more than the water height, so it only does it for the land, doesn't do it for the water. There you go. And in fact, what we can do is have a different threshold to the sea level. So we can say the sea level is at 90, but if our isolines are drawn at 70, they'll go into the sea a little bit. So let's see the effect of that. There you can see now how the isolines are drawn into the sea a little bit, but not too far into the sea. So the isolines start at height 70 and the blue colour goes up to height 90. The land starts at 90 and above. So that's quite a nice effect. I haven't got the nice beige colour for the land, so I'm going to do that. In fact, what I might do is I might just say I'm going to draw a background rectangle to be drawn over. So I'm going to say fill 255, 229, 202 as my kind of beigey colour, like sand colour. I'm going to draw a rectangle that covers the entire canvas. As you know, that should be 599 to be technically correct, I think. But there's no major problem by doing that. I was going to do 800 by 600, but it's actually 799,599, just to be super correct. But there's no harm in doing it with a nice round number. So let's see the effect of that. So I've got a nice sand-coloured background, and then I've drawn the sea on top of that, and then the ISO lines on top of that. Now I wonder what would happen if I made the sea a little bit, I guess the sea depend a little bit on the noise value. So deeper water has a slightly different colour, and we can do that because we've got the information. The noise value is the elevation. So I could say for the blue water I'm going to have a lighter blue, so I'm going to say 150 red, 150 green, and then 150 plus N, and I'll give it a translucency because they do overlap a little bit, these. Let's see the effect of that. There's a kind of a greyness that's at it's not very apparent. Still a nice effect. Let's rather than being on beige, let's put them on white colour. So this probably isn't the most efficient way to do it, but it's just the idea. We're just refining it. So we're laying down a white and then putting on the oh, okay, yeah, I can come back to that. We can probably apply some other mathematical kind of transformation to make the deep sea even darker. I'm going to try the same idea with the height of the ISO lines. If I make them depend on the height, depend on the kind of noise value, I can say fill noise n over 2, so half the n. Remember, n goes up to 200, so now it's going to go, n over 2 means 0 to 100. And why that? Because RGB goes up to 255, so we want it to remain fairly dark. Give it a translucency. Okay, so they're much lighter here, aren't they? A bit too light. Maybe I can change the size of that circle to also depend on the height. So a tan function is nice because it means a tan H. So you might remember, again, there's a previous video exploring useful mathematical functions. So -1, +1, 0. The tan H function does this. It goes towards +1 and it goes down to -1, goes through 0, and it's a useful way of kind of saturating towards +1 as your input value gets larger. So what we can do is say, as the height noise gets larger, if we do a tan H of noise, as the noise gets larger, our circle size approaches 1, which we can multiply, of course. We can say 3 times that. And we can scale it by some factor like divided by 10 or 100 or 500. That should mean that as the height gets larger, as the noise gets larger, this approaches 3, no more. That's the point of this function, is that it doesn't go above a certain height. And as n goes to 0, then this function, this thing that we've created, goes towards 0, which is fine for us. In fact, why don't we do the other way around, so that the higher you are, that's inverted, so we can say 1 minus that, so 1 minus tan h. That would mean, let me choose a different colour. So 1 minus that would be, no it wouldn't. It would be 1 minus this, it would be that. So what does that give us? That gives us, as n gets larger, 1 minus tan h of n, suitably scaled, goes towards 0. So the higher we are, the thinner the isolines, and the lower we are, 1 minus tan h n goes towards 1, which we can scale up. Right, that was a complicated way of saying the higher we are, the thinner the isolines. So math.tan h of n, let's divide that by a scaling factor, and then we're going to say 1 minus that to invert it, and then we're going to scale it 3 times. Let's see the effect of that. Oh, done some error somewhere. Yep, 3 times, not 38. And I've made an error here. That should have been divided by 2, comma 2. There you go. That might be why those lines are really, really pale. So actually, with not too much work, we've arrived at a bit of code. Let's see look how long it is. Not very. Let's just kind of go through it. We're drawing a rectangle that's sand coloured. I'll just do that. Sand coloured rectangle. Just sand coloured background. And then we're visiting every point on the canvas. We're picking a noise value which goes up and down in a random but smoothly random way. We're saying that if the level is below seawater, colour it blue, and we can think of different ways of doing that. I won't spend time today kind of making the deep sea water even darker, but you can certainly do that by playing with the n value. And here we've said that if it's above, I'll put the comment in, land. So not isolines for land. So if it's above seawater, above 90, or actually above 70 here, we're going to draw isolines, and we're going to draw them only at every 10, height 10, every 10, so 10, 20, 30, 40. And you can again refine how they're drawn, the style in your own way. I've just introduced a little bit of mathematical fanciness, but even without it, you saw that the effect was really quite effective. And this creates something that has the feel of an old style map. There you go. Great, so I'm going to stop there, but this should give you enough to play with yourself, to refine, to experiment. You can perhaps choose maybe even different colors for the isolines. You can perhaps make the color of the land change with height as well. That's something you can have a go at. You can try to do what I didn't quite achieve today, which is to make the deep water areas even darker. You can certainly do that. But the main idea I wanted to show was how to use noise combined with the kind of remainder function, the modulo function, to create nice, realistic looking isolines. I'm going to run it one last time because I do enjoy how organic it looks. There, lovely. I'll stop there. I hope that's given you some ideas and some inspiration, and hope you've enjoyed that. See you next time. Bye.